Hello, Algebra 2 students, and welcome to the first part of Unit 5, where we look at polynomial expressions, equations, and functions. The idea behind this unit, we spent 2 units on quadratic things, quadratic expressions, equations, and then a whole unit on quadratic functions, parabolas. This whole unit is going to be about taking those ideas that you saw with the parabolas and the quadratic equations and seeing how we can kind of adapt those ideas if we have powers higher than just 2 in our equation, in our function, in our expression. And that's what we're going to take a look at over the next 2 weeks. To get us started, though, there's a lot of vocabulary that we need to go through. And I figured I would do this through a PowerPoint rather than just me kind of writing notes and all that stuff. So we are going to start on page 3 in your notes. Everything in your notes should match up with everything in this PowerPoint. And like usual, since this is Edpuzzle, it'll stop, it'll ask you questions and all that good stuff. And, well, let's get moving. First term that So the first term that we're going to define is a monomial. A monomial is a constant, a variable, or a product of constants and variables. Some examples of monomials are shown on the page below. 2x, 4y, z squared, 6, negative 27x cubed y to the 7th. These are all examples of monomials. They're either constants, variables, or in pretty much all the other cases, except for 6, the product of constants and variables. 2 times x, 4 times y, z times z, negative 27 times x times x times x times y times a whole bunch of y's. These are all examples of monomials. Take a moment and make sure this is all in your notes. Now, every monomial has a number associated with it called the degree of the monomial. And really, the degree of a, single variable monomial. We're only going to focus on monomials that use x's or y's or z's, but not x's and y's and z's altogether. To find the degree, it's just the exponent of the variable. The degree of a single variable monomial is just the exponent of the variable. So we're going to take a look at 3 different monomials, and I want to find the degree, just the exponent of the variable. Or another way we can think about this is the degree is basically the number of that variable we have multiplied together in the problem. I have a variable over here of y. I have 4 times y times y times y times y times y times y. I hope I counted that right. Maybe I was one short, whatever. How many y's, how many variables are in this big multiplication problem? There are 6. The degree of that first monomial of 4y to the 6th is just 6. Yes, there were 6 y's in that multiplication problem, but honestly, you can just think about this as what's the exponent of the variable. How about that next one, 2x? Any thoughts as to what the degree of 2x might be? Well, I'm looking at the x. I don't have an exponent there, which means the exponent's like a 1 over there. So the degree of 2x is just going to be 1. How about 5? Any idea what the degree of 5 will be? I don't see any variables here with my 5. Therefore, my degree of the constant 5 is just 0, because there are no variables there. All we're really looking for is the exponent of the variable. Now, we need to look at how to put different monomials together. Actually, not really how to, just what to call them when we put them together. First, a binomial is the sum of 2 monomials. Mono means one, bi means two. A binomial is just the sum of two monomials. For example, x cubed plus 4x is a binomial. It's the sum of two monomials. Well, mono means one, bi means two, tri means three, like a tricycle has three wheels. A trinomial is the sum of three monomials. For example, 2x to the fourth minus 3x plus 1 is a trinomial. Monomial, one term. Binomial, two terms that we'd be adding together. Trinomial, three terms that we're adding together. And then we come to polynomials. Poly, that prefix means many, the sum of many monomials. Or really, why don't we just write this as a polynomial is the sum of any number of monomials. For example, x to the fifth minus 3x plus 4 is a polynomial. X to the sixth minus 2x to the fourth minus 3x squared plus x is a polynomial. Actually, every single thing we've looked at so far in this PowerPoint is an example of a polynomial. Now, this first one has a better name. We could call it a trinomial because there are three pieces, but it still counts as a polynomial. Polynomial is really the umbrella term for all these things that we're dealing with in this unit. These things that we've seen so far are what we will be spending this unit looking at. I'm going to make the video pause so you can take a moment and make sure all this is in your notes. Just like we have the degree of a monomial, we can find the degree of a polynomial as well. And again, we're just going to stick with polynomials that only have one variable in them. That's all we're going to have to be able to deal with. But to determine the degree of an entire polynomial, all we're going to do is look at each of the monomials and tell the degree of the monomial with the highest power. To determine the degree of an entire polynomial, we're going to look at all the different monomials in there. The monomial with the highest degree, that degree is also the degree of the polynomial. Let me show you some examples. Let's take a look at the polynomial x to the fourth minus x cubed plus 6x minus 2. I want to find the monomial with the highest degree. Well, the degree of x to the fourth is 4. The degree of minus x cubed is 3. The degree of plus 6x is 1. The degree of minus 2 is 0. So the degree of my entire polynomial is going to be the highest degree that I just saw. It's going to be 4. The degree of this polynomial is 4. You try this one. What's the degree of y to the third minus 7y to the fifth plus 9y to the seventh plus 2? Well, it's the monomial with the highest degree. I've got a 3, I've got a 5, I've got a 7, I've got a 0. The degree of the entire polynomial is the highest number I just said. It's going to be 7. The degree of this polynomial is 7. Now, there's a certain order that we usually write polynomials in called standard form. And you've seen this before. We actually kind of had this with our quadratic polynomials. I know you saw this in Algebra 1. To write a polynomial in standard form, we are just going to rearrange our monomials so they go in order of decreasing degree. To write a polynomial in standard form, we are going to arrange the monomials by decreasing degree. So for example, we're going to put x to the fourth minus 2x plus 3x squared minus 5x to the sixth minus 1 into standard form. I need to rearrange these 5 terms so it goes in order of decreasing degree. Well, the term with the highest power, 4, 1, 2, 6, 0, is negative 5x to the sixth. When I rearrange these things, I'm going to start with negative 5x to the sixth. What will the next term be? I think the next term should be x to the fourth. And after that, we'll have 3x squared. After that, the minus 2x because that degree is 1. And after that, we'll have that constant, that minus 1, because the degree of minus 1 is 0. So my final answer, negative 5x to the sixth plus x to the fourth plus 3x squared minus 2x minus 1. Make sure all of this is in your notes. So now we're going to move on to naming polynomials. And when we name polynomials, we give every polynomial 2 different names. One name according to the degree, and one name according to the number of terms that we have. So we're going to look at these 2 different ways to name them, and then when we go and actually start naming some polynomials, we'll give every polynomial 2 different names, a degree name and a number of terms name. As far as naming by degree goes, well, we're going to fill in that chart that you have in your notes. If I have a degree 0 polynomial, I'm going to call this a constant polynomial. Like if my polynomial is just the number 7, we call it a constant polynomial, because 7 itself is just a constant. If our degree is 1, like 3x minus 7, we call this linear. You know that if we go to graph y equals 3x minus 7, that graph is a line. You spent a lot of time on Algebra 1 on that. If the degree is 2, if our highest power is 2, any ideas what we're going to call it? And I'll give you a hint. It starts with a Q. We just spent 2 units on this. If the degree is 2, we're going to call it quadratic, like 2x squared minus x plus 3. We looked at quadratic expressions, quadratic equations, quadratic functions. If the highest power is 2, we call it quadratic. If the highest power is 3, we call it cubic. 7x to the third plus 5x squared minus 1 is an example of a cubic polynomial. If our degree is 4, highest power is 4, we call it quartic. Negative x to the fourth plus 2x squared minus 2 is a quartic polynomial. Well, for 5, if someone has 5 kids, 2 kids are twins, 3 kids are triplets, 5 kids are quintuplets, and a 5th degree polynomial we're going to call quintic. Degree 5 we call quintic. 6x to the 5th, it's a quintic polynomial. And we're going to get one more in the chart. If the degree is 6, there is no special name. We call it a 6th degree polynomial. And we're going to do that for everything above 6. A 9th degree polynomial, a 12th degree polynomial, a 100th degree polynomial. I'm going to make the video pause so you can make sure this entire chart is in your notes. So we're now going to make a chart for how to name polynomials according to the number of terms that they have. And honestly, these names are going to sound very familiar. We already got these in our notes somewhere else. We're just going to kind of put them in a chart here. If we have one term, we call it a monomial. 3x squared is a monomial. Two terms, binomial. X to the fifth minus 4x squared is a binomial. Three terms, trinomial. X squared plus 3x minus 1 is a trinomial. After that, we have no special name. So if there are four terms, we call it a polynomial with four terms. X to the third plus 2x squared minus 5x plus 7. There were five terms, polynomial with five terms, 20 terms, polynomial with 20 terms. Please make sure this whole chart is in your notes. So the next thing we're going to do is we're going to put some polynomials into standard form, and then we're going to name them. Example number 1, 9 plus x cubed. Actually, you see what you can do here. Actually, see what you can do in both of these. See if you can put both of these examples into standard form, and then come up with the names. Example number 1 is going to become x cubed plus 9 when it's in standard form. What two names would you give it? Well, highest power is 3. That makes it cubic. There are two terms here. That makes it a binomial. We're going to call this a cubic binomial. In example 2, when you put it into standard form, should become this, negative 3x to the fourth plus x cubed minus 2x squared. What name would you give it? I'm going to call this a quartic because the highest power is 4. Quartic. Trinomial because there are 3 different terms to it. Yes, these names will need to be memorized. However, I feel like we're going to be using them so much throughout this unit that you won't be able to help but just have them memorized. You're going to know these, and this won't be a big deal, but we will be using these terms all unit long. Okay, a few more vocab things to look at. The leading term of a polynomial is the term, or the monomial, with the highest degree. And going along with that, the leading coefficient is the coefficient, the number part of the leading term. I'm going to show you one example of this, and it's not going to be a big deal. We're going to find the leading term and the leading coefficient of the polynomial 4x to the sixth minus x cubed plus 5x squared. But before we do that, make sure you have both definitions in your notes. Okay. The leading term. Well, the leading term is the monomial with the highest degree. I have a 6, a 3, a 2. I think the one with the 6 is the one with the highest degree. My leading term is just 4x to the sixth. The leading coefficient is just the coefficient, the number part of that term. What's the number part of 4x to the sixth? Well, just going to be 4. My leading term is 4x to the sixth. My leading coefficient is 4. It's really easy to find these if our polynomial is in standard form, because we're just looking at the first term as we go in decreasing order, and the number part of the first term. That's all we need to do. 3 more terms, and we'll be set with this video. There are 2 others you're going to watch during the rest of the period. I know we've seen these terms before, expressions, functions, and equations, but I just want to kind of define them in terms of polynomials, because we're going to be looking at polynomial expressions, polynomial equations, and polynomial functions as we go through this entire unit. Polynomial expression. Maybe something that looks like this, x to the 6th plus 5x to the 4th minus 2. We can rearrange the terms. We can add these things, subtract them, multiply them, divide them, name them, factor them, but that's all we can do. We can just kind of change the order and do things with them, but we can't solve them, we can't graph them. Those are expressions. As opposed to polynomial equations. Polynomial equations, things that we can solve, and we can get number answers out of them. 2 polynomial equations are on your screen right now. X squared minus 4x equals 0. X to the 5th minus 3x squared plus 1 equals 0. We saw polynomial equations like that top one, and we saw that when we solve those quadratic equations, we get 2 solutions. You want to take a guess how many solutions we might have to a quintic equation if there were 2 solutions to a quadratic equation? Any ideas how many solutions to a quintic equation? We're going to get 5 solutions to a quintic equation. And by the time we're done with the chapter, we'll have a couple different methods for trying to solve things like that. Finally, polynomial functions, things that we can graph. 2 examples of polynomial functions are on your screen right now. F of x equals x cubed minus 2x squared plus 1. Y equals 5x to the 7th minus 3x to the 5th plus 2x minus 1. You're going to be graphing very, very basic polynomial functions by the end of class today. Tomorrow, we'll start looking at things more complicated, more like what you see on the screen right now. And then we'll do a bit more with that stuff on Thursday and Friday. Please make sure all of this is in your notes. So you are not done with the work for today. There are 2 other videos you're going to watch. One is going to finish up the notes in section 5.1 about polynomial operations, how to add, subtract, multiply these things. We'll save division for a little bit later. And then you're going to do a very small bit of graphing. It is a very, very quick video because you already know the basic ideas of how to graph things. We're just going to kind of apply the rules you already know to a cubic function, and you'll see that in the 5.2 video. See you later.